Okay, well, hope everybody's having a good day. You'll notice I went ahead and tried to get those copies to you as quickly as I could. One of the packets you picked up on the way in today is your Math Studies booklet. So if we go ahead and take a look at this real quick, and we start to go ahead and go through, you're going to notice a lot of things that you learned a long time ago. A lot of this that I mentioned yesterday as a review is going to be coming back. Everything from, area of a figure all the way to distance between 2 points, the midpoint. All that seems familiar? Okay. Of course, it's probably been a couple years, since geometry. Hello. Hey, come on in, guys. Oh, thank you. And then let's go ahead and actually just kind of take a look at where we're sitting, how much more we have to go, and how much we've already covered. So this is the formula booklet that you're going to be provided when you take the paper exams coming up in May. I believe it was the 13th and the 14th, that Monday and Tuesday. So you'll notice topic 1, number and algebra. Well, we've already taken care of percentage error. Arithmetic sequences, both finding an nth term, finding the sum. We are currently working on geometric sequences in the series, and we're actually hopefully going to finish that up today, if not definitely by tomorrow. And the only thing we haven't completed here is compound interest, and that should be coming up probably the week, maybe next week late or a week after next. Okay. Descriptive statistics, mean of a set of data, interquartile range. Hopefully those are items we're going to remember. As far as the truth table goes, you'll notice it does give you a completed truth table. The questions are more going to be based on like maybe writing a sentence or answering questions about the particular scenario. And we're going to be able to see more of those in the future as I start to give you practice tests. But just a quick review. What does that sideways L mean? Okay, negation. The upward arrow? That's the intersection. That's and. Downward? That's the union. Okay, what word is that? Or. Okay, very good. Now, what's the difference here? We have inclusive and exclusive. Which one was which? So exclusive, what did you say, Caitlin? So she says exclusive has the bar, inclusive does not. Would you guys agree? So what's the difference between them? That's exactly right. Okay, so just in case it didn't pick up on the microphone, inclusive was one or the other or both. Exclusive was one or the other, but not both. There we go. What does the arrow mean if it's in one direction? Implication, those are your if-then statements. And then if it's in both directions, that's equivalence. In order for that to be true, the implication must be true in both directions. There you go. Okay, and then we talked about probability, complementary events. It goes all the way through mutually exclusive, independent. Remember, we spent time on those, all the way to conditional probability. In fact, what's the key word we looked for with conditional probability? Given. Okay, one event given another. There we go. Now, here's some stuff that, again, we have not yet talked about in here. It's coming up in the next month or so, but you will have seen. So equation of a straight line, y equals mx plus. Typically we say b, but you know how IB kind of does things slightly different. So they're saying c here. You also have ax plus by plus d. Does anybody know what we call that? Starts with s. Standard form, yes. You'll probably recognize it as ax plus by equals c. It's just switching the variable around, but it's still the same type of equation. In IB, we don't say slope, we say gradient. Okay, that's just another word here. But the difference of the y's over the difference of the x's. How many people in here are familiar with trigonometry? Like just the basics, like let's say sine, cosine, and tangent. So I know some people, like the ones I taught, are probably definitely, hopefully going to raise their hands. But if not, we're going to start with the basics. I am going to be showing you the law of sines and the law of cosines after we do a little bit of review on that. So I'm hoping that's a little review. If not, that's fine. We will take care of it. Now here's a bunch of stuff, again, you will have seen in geometry, but again, we just haven't talked about yet. Surface area, lateral area, volume, all that good stuff. So all this is provided for you. And then we finish up quadratics. Does this look familiar? Do you guys remember being taught that in Algebra 2? Okay, that will give you the location of the minimum or maximum in a quadratic, basically the x value of your vertex. Maybe you recognize it like this. The vertex would be the opposite of bay, no, wait a minute, over 2a divided by, I don't know what to do, over f of b divided by 2a. Does that look familiar? That's the actual vertex. Super quiet in here. So I'm going to take no, we don't recognize that. We do recognize that. Oh, we don't recognize that. Okay. So that is something we will definitely talk about. And then the very last topic we are going to have of the school year before we get to the review, before we go ahead and start getting to all of the tests, is differential calculus. Basically, I'm going to be showing you how to take the derivative. I'm going to start you off using what's called the difference quotient, and then I'm going to show you the shortcuts. For those folks I've taught before, do you remember the difference quotient? You remember from calculus? Could you tell it to me right now? Oh, okay, all right. Who else have I taught previously? Anybody else? Haley, do you remember that?
The what again?
The difference quotient? Basically the universal method for finding a derivative? Just kind of did it? Okay. Does that look familiar? So it does look familiar. Okay, good, good, good. So that's something probably that's going to be brand new to a lot of people. But hopefully you're seeing, looking at this formula booklet, I cannot talk today. We've covered a lot of topics. There's going to be a lot of information on there. Statistically, the formulas, they really didn't show a whole lot, but you can definitely expect there's going to be some type of chi-squared problem. There's going to be some kind of standard deviation, going back to all those stats ideas. And we're going to be reviewing those as well. But they're really not providing you formulas because it's really all done what? On the calculator, and that's really what we want to make sure that we're very familiar with. So you can see there's a little ways for us to go, but I wanted to go ahead and get this to you as quickly as possible. So you have that now, and I double checked. This one was edited, I want to say, in 2015. Yeah, it was the last time it was changed. So this should be up to date, is what I found on their website. The other piece of paper that you picked up on the way in, this is the factoring map, and unfortunately I don't have a slide to show you, but one side here with all the ovals, this walks you through exactly how to factor any polynomial that you come across. The first step, always look for a GCF. What does that mean? Yeah, greatest common factor. Is there any term that's common to every one of the terms in your expression? And then from there, you'll notice it goes down based on the number of terms. If it's a binomial, you're going to be checking, is it a difference of squares? Is it a difference of cubes or a sum of cubes? If it's 4 terms, does anybody remember grouping? Okay, grouping. Okay, so some people are yes, some people are no. Now, the biggest one is going to be the one at the bottom. If you're factoring a trinomial of this form, ax squared plus bx plus c. Okay, now factoring, we're looking for the binomial expressions that would multiply to give me this trinomial. So there's probably a lot of folks who remember a lot of different ways. How many people, the first thing they think is guess and check? Okay, so maybe your teachers use guess and check. Any of your teachers use the box method? Grouping on this is another one. What I like to use is detailed right here. It's called My Father Drives a Red Mercedes Convertible. Now, it sounds odd, but I like that better than any other strategy because if it's factorable, guaranteed it's going to break it apart for you. It's a really simple process. It's kind of like, please excuse my dear Aunt Sally. What do you think when you hear that? Yeah, PEMDAS, parentheses, exponents. It's the same thing with the My Father method. The first letter in every word is a step that tells you exactly how to factor those. And it doesn't matter if it's simple or general. And what's the difference between simple and general? When I'm talking about quadratics, do you guys remember? Let me give you an example. Let's say if I were to have 2x squared plus 7x plus 4. Simple or general? Well, we got a 50-50 shot. I heard simple, I heard general. It is general. Why? No, that doesn't play a part. Now, if I make one change, now it's simple. What did I remove? There you go. It just deals with the coefficient of the quadratic term. If it's 1, it's a simple trinomial. If it's anything but 1, it's what we call a general. Okay. So typically, if it's something like this, if I were to change this to maybe 10, using guess and check, people could probably break that apart pretty easily. But it gets a little more difficult for some folks if you were to have something like, 5 in front of that. Okay. And then basically that's what I like to use is this method. Now, I'm kind of getting a little ahead of myself, but if you already have a method that you feel really comfortable factoring a trinomial such as this, please continue to use it. I'm going to go ahead and show you the method that I like just because I think it's a great method. Okay, in fact, let's ask the students who I taught previously. Sydney, what'd you think of my method? The my father method for factoring trinomials that I taught you. You don't remember any of that? Okay. Haley? She liked it. There you go. That's enough confirmation for me. All right. Ubis? Okay. There you go. Like I said, if you have a method, that's great. Now on the back, it just gives you a few specific examples. There's a sum of difference of cubes right there. There's a grouping example. So this is just for your benefit. Some folks yesterday said they wanted me to go ahead and give you that in preparation for what's coming up. So any questions about the formula book or the factoring sheets? Okay, well, let's go ahead and get right back to it. What's happening tomorrow while I go ahead and pull this up? We have our quiz over what kind of sequences and series? Arithmetic. Tomorrow is going to be arithmetic. We are currently talking about geometric sequences and series, but tomorrow it's going to be arithmetic. And here are the formulas you're going to need. I think specifically I give these on the quiz. I'll probably just have the nth term formula on the board someplace. Almost positive I put it on the quiz, but if not, I'll have it up on the board. So if you have any last minute questions, definitely come on in. Let me help you with that. But geometric sequences and series, what we started yesterday, is not on the quiz. All right. So speaking of, let's see. I think we got through the first 4 problems, right? Okay, here we go. So just a quick kind of review to get us back into it. What was the nth term for finding, or the formula for finding the nth term in a geometric sequence? Grayson? What was that formula we were using yesterday? There we go. Times r to the n minus 1. So with arithmetic sequences and series, remember we were just adding or subtracting the same value over and over again. That variable was d. It was the common difference. Here in geometric sequences and series, the variable is r, and it's the common ratio. So we're constantly multiplying by another value to get the most current term. In fact, consecutive terms, we take 1 and divide it by the previous term in order to find r. Okay, so let's just get right back into it. Now, here's where we have to be careful, and I don't want to confuse folks, because is a geometric sequence an exponential expression? Yes. So let me go ahead and write out this formula that we have right here. So u sub n is equal to u sub 1 times r to the n minus 1. This is the formula for the nth term of a geometric sequence that we were looking at yesterday, but you might remember this going back to Algebra 2. If you want to write the expression or equation for a exponential, okay, a, the amount typically is what you would start with. We have a naught times, okay, 1 plus or minus r to the power of t. Again, the variables are slightly different, but that doesn't matter. Does anybody recognize that? Okay, so hopefully some do, some don't. What does r represent here? Okay, what's that, Libby? Yeah, it's your percentage rate. That's exactly right. Okay, and we go ahead and add or subtract that percentage from 1, because if it's a growth, we're going to add it. If it's a decay, remember we were going to subtract it. T was what? T was time in years. And A naught is what? The starting number. That's the initial value. So when you're looking at a problem like this, and I know you've seen problems like this for a very long time. Let's just see what it says. A car whose original value was $34,000 loses 15% of its value each year. You can either write this using the geometric formula, or you can go ahead and write it using the exponential formula. Personally, I kind of put the geometric sequences to the side and I go ahead and write it with exponentials because I'm much more comfortable in doing that. But there's just one thing you want to be careful of. In using either of these, you have to be careful in what value is your very first term. Okay, so if I'm going to go ahead and say that the 34,000 is the very first term, which formula would I be allowed to use? Would it be the geometric or the exponential? Okay, it'd be the geometric. Okay. Now, if I were to go ahead and apply the 85% and find out the value after the first year, if I were going to go ahead and say that was my first term in the sequence, then I would be okay to go ahead and use this guy right here. Okay. The only thing is, if I'm going to go ahead and say this is my first term, think about what the problem says. We're finding the value of the car after 6 years. What term number am I actually finding? So I'm starting with the 34,000, and I'm wanting to find the value after I apply the percentage how many times. So I'm really trying to find the 7th term. See, that's where you kind of have to be careful. Okay, so let me go ahead and do this. First, let's set this one up just so we have our percentage here. What's the starting amount? It's 34,000, right? And y'all realize as soon as you purchase, what are we talking about here, a car, the very instant you roll the car off of the dealership, it's probably already lost a good $3,000. Okay, everybody's realizing that? Depreciation happens very quickly. So we're not going to worry about that. We're just going to go with what the problem says, 15% per year. So because it's losing it, am I going to add or subtract? Subtract. And we're going to want to change that to the decimal value. So 1 minus 0.15. So my base is what? 0.85. Okay. And then, t is the variable that typically the different resources use because it represents time. But the variable itself doesn't matter. I mean, it could be x or n, anything. And then a, of course, would be the amount after t years have passed. So, there's one of two ways to look at it. You could say you're losing. Hello. Michelle? So you could say you're losing 15% every year, or you could say you're retaining what? 85% of the value. So it's kind of just a different perspective way on looking at that. Okay, now what we were talking about a second ago, if you decided you wanted to go ahead and use this formula right here, the first term is not the initial. Oh, excuse me. Wait a minute, did I mess up? Hold on, I wrote this on my paper. I think I may have messed up for a second. I know it's hard to believe. Mr. West messing up, right? Okay. Yes, I'm sorry. We actually said that this would be the first term, and then I went ahead and wrote it over here. Anybody tell me what the first term actually should be? What am I going to multiply this by? 0.85. 0.85. There we go. Okay, so 28,900. My apologies on that. That should actually be 28,900. You'll use the exponential if you're going to say that the value after that first year is the 15% off. Okay, we actually said this. So this one's going to be the 34,000. Sorry. Okay, times 0.85 to the n minus 1. Okay. All right, there we go. Does that make sense? Okay. So like we said, if you're going to use the geometric and you're going to say that the original value of the car is your first term, okay, you're really actually trying to find, in this case it wants 6 years, so we're trying to find the 7th term. So this is going to be u sub 7 is equal to 34,000 times 0.85 to the 6th. Hello. Okay. Caitlin. All right. Whereas over here, okay, you've already taken the first year, so you just go ahead and plug in what you need. Okay, so let's come on over here to the calculator. 34, of course it did. 34,000. I'm thinking I might need to use the mouse because this is not working. Okay, parentheses. I'm going to use my mouse. I think that'll just make things go a little faster. Oh, and it actually typed in J. Good. Okay, so 34,000, parentheses, 0.85. See, now we're going a lot faster. To the power of 6. Okay. So here we go. $12,823.10 should be the value of the car after 6 years. Okay. So you can do, whichever you want. You just want to be careful. If you're going to go ahead and write it using the formula, okay, if you're going to say that the value is the first term, well, then you're actually trying to find the next term, the original plus however many you're looking at. Okay, I know that kind of doesn't make sense. If you're looking for the exponential, then you can just go ahead and plug in. Okay. Good. Okay. Now, after how many years will the value of the car fall below $10,000? Okay. So for this one, I think I'm just going to go ahead and go back to, well, you just want me to go ahead and bless you. You want me to go ahead and stick with the geometric? Okay. Let's just go ahead and use the one that we had. So we started with 34,000. Okay, times 0.85 to the power of n minus 1. Now, we're interested in when this value is going to fall below 10,000. Okay, so really when it comes down to it, you're looking for the amount of time it's going to take to hit the $10,000 mark. So here I did go ahead and put less than because it does represent an inequality, but even if you put an equation, you would still just know what it is you're talking about, right? Is everybody okay with that? Questions? Okay. Now, we could go ahead and run through this. In fact, how would I solve it if I were to go by hand? Okay, let's go ahead and divide by 34,000. What's the word I'm fishing for that we talked about yesterday? It starts with an L. Logarithm. Okay, so that's going to cancel. 0.85 to the n minus 1 is going to be less than. And what would that be? I think I had it on my paper here. I'm ending up with 5/17. Okay. Okay. And then now what? Okay, take the log. Now remember there were 3 parts to every logarithm and exponential. 0.85 is your base. N minus 1 that's the power exponent. And 5/17 is your argument. So I could go ahead and say log of base 0.85 of what? 5/17 equals the n minus 1. And just because we're about to plug this in the calculator, since we won't have to worry about the inequality, I'm just going to go ahead and make that equals, and we'll know that it has to be more than that particular amount of time. Okay, that's just going to make it a little easier because there are a few tricks involved with a logarithmic inequality, and I really don't want to get into them right here. So log of 0.85 of 5/17 is going to equal n minus 1. So I'm just going to go ahead and change one thing. I'm just going to go ahead and add 1 over here, and that should help me figure out the number of years that I'm looking for. Is everybody okay with that? Okay. So let's see. Let me plug this in. I'm just going to go right back over to the calculator because the touch screen's been working so well today. Let's see. 1 plus. So I'm going to hit Control. Now 10 to the x. That was 0.85 of parentheses, Control divide 5/17. Okay, whoops. Okay. Hello. Hey, Daniel, how you doing? Okay. Louise. Okay. All right, so what are we getting? About 8.5 years? Okay. All right. Now, if I were just to go back, now remember, if you were to go ahead and put some of your work, which I always recommend on a problem like this, especially when it comes to the paper exams, showing work, even if you get it wrong, the error can carry forward. So it could potentially give you points on a paper exam, but you could also just type it in like we did yesterday. How do I do that? Algebra, numerical solve. So let's see here. What was it originally? 34,000 times 0.85. Okay, and I'm going to go ahead and say per to the power of, and I'm going to put parentheses in there. I'm going to change that to x minus 1. Okay, where's my equals? Well, remember, we got to put what it's equal to. Okay, right below the control button. So equals 10,000, and then we're going to put comma x, right? Okay, so now as soon as I go ahead and push enter, okay, questions? All right. Well, good. Okay. And there we go. Next up, the number of people in a small town increases by 2% each year. If the population at the start was 12,500, what's the predicted population at the start of 2010? Okay. All right, so I'm just going to go ahead and use this as a good old-fashioned exponential. Okay. So what are we starting with? 12,500 is my initial amount. Okay. So 12,500. Okay, so the amount of people is going to equal times, what would my base be? Think about the 1 plus or minus r. So it's definitely increasing. So 1.02, because 1 plus the 0.02. Okay. Then, of course, you would raise it to the number of years. So what am I going to raise this to? 40. Where are you getting the 40 from? Yeah. 1970, of course, I think mine's off the screen, but it goes to 2010. Yeah. Yeah, because it's still on your paper, right? Yeah. It's just like there's a big gap there. I don't know how that happened. So to 40. There we go. So 12,500. Let's see what we got. This is going to work. 12,500. There we go. Parentheses 1.02 to the power of 40. Okay. So after 40 years, population should have increased. Now, here's the thing. We always want to talk about our answers being reasonable or unreasonable. Okay. What kind of answer would be unreasonable when you're talking about number of people? Yeah, like decimal values, negative values, right? Okay. So here I'd probably go ahead and say 27,601. Okay. Yeah. I mean, see, and that's the argument. I mean, there are good reasons on both sides to go ahead and round up or down because it's 0.5, and I don't know if there's any more to this decimal. Now, because it said 0.49, that might kind of lead me, since it isn't actually the 0.5 until we rounded it, that might make me lean a little more towards rounding down. But this is just an estimation because think about in the real world situation, could there be other factors that affect this? Yeah, I mean, for example, are we going to be guaranteed that every single year for 40 years, this town or whatever it is going to be experiencing 2% growth? Yeah, I mean, we can't guarantee that. So really, this is just a prediction. Does that make sense? Okay. And I've always had students in the past, well, what if somebody doesn't have an arm? Well, they're still a full person. You don't say like 3/4. Well, this is just the amount. Now, we're not talking about series, no sums yet. So if it just increases by 2% each year over the 40 years, this is predicting what we should get. Yes. How many people are there? No, this is the number of people. So if you want the increase, I would go ahead and subtract the original amount. Does that make sense? Okay. All right. So is a lot of this coming back from exponential algebra 2? Okay. We love exponentials and logarithms. Okay. Logarithms are always fun, right? Okay. Okay, good. Good. Okay, well here, I believe this is our last topic in this section, geometric series. If the terms of a geometric sequence are added together, the result is known as a series. Just like an arithmetic series, however number of terms you're wanting to add in your sequence, we call that a series. Same thing for geometric. Now, we have specific formulas depending on what your common ratio is. Now, here, we take it as the absolute value because the common ratio could be positive or it could be negative, but the absolute value, if it's less than 1, then the sum of the series is going to be this formula here. The first term times 1 minus the common ratio to the number of terms you're adding divided by 1 minus r. Okay. If the common ratio's absolute value is greater than 1, this is the formula you're going to be using. Okay. And let's just go ahead and get an example. Find the sum of the first 9 terms of the series 2, 4, 8, 16. Okay. So first, in order to figure out what formula I want, I need what? I need that common ratio. So R is going to be to take one term and do what with the previous? Divide it. So like 4 divided by 2 will give me 2. 8 divided by 4, 16 divided by 8. So we're multiplying by 2 each and every time. So is it the first or the second? It is the second one. That absolute value of 2 is greater than 1. So we're going to have u sub 1 times r to the n minus 1 all over r minus 1. Okay. Well, what's the first term? 2. And that's why I like these kind of problems right here. Really, it's just very straightforward. These are the kind of problems you're going to want to see on the paper exam. You're just plugging into the formula and you're simplifying. Okay. So r is 2 to how many terms? We want the first 9 terms, so that's n. 2 to the 9th minus 1, and this is all over 2 minus 1. So here it's actually pretty nice to us. That's actually just 1, and what's anything divided by 1? Yeah, itself. So I really don't even have to put that in as a fraction. Okay, and I would just plug in that expression. So 2 times 2 to the 9th minus 1. So 2, parentheses, 2 to the power of 9. Okay, this is going really slow. There we go. Okay, and of course we could put divide by 1, but not necessary. So what should I end up with? Okay. All right. 1022, is that what you guys are getting? There you go. And again, it's another one of those, it's not a whole lot. How hard would it be to get the next 5 terms in the sequence? Wouldn't be difficult at all, right? And then you can just sit there and add them up. But, if you're asking for something much, much larger, definitely want to use the formula. So 1022. Okay, questions? Anybody having a hard time? No? Okay. Well, let's see here. Find the sum of the first 12 terms of this series. 24 plus 18 plus 27 halves plus 81 eighths plus ... Okay, so let's figure out what r is first. So I'm going to take a term. I usually start with the second term and go ahead and divide it by the previous. And what is 18/24? Okay, 3/4. All right. Would anybody like me to go ahead and take another pair of consecutive terms, divide them, and see if we get the same thing? Okay. All right. So with our value of r, the absolute value, that is, being less than 1, we're now going to be using the first formula. Okay, so u sub 1 times 1 minus r to the n over 1 minus r. Okay, so u sub 1 times 1 minus r to the n over 1 minus r. Okay, so the key here is just knowing which formula you want to use. Is everybody okay with how I'm deciding which? Music? Okay, well, we know the first term is 24. That's u sub 1. times 1 minus, we found R to be 3/4. We're going to raise that to what? To the 12th, because we want to add the first 12 terms of the sequence. So that's to the 12th. And then we're going to go ahead and take 1 minus 3/4. Okay. Now I would definitely go ahead and plug in the expression as we have it. I would probably want to simplify it myself just a little bit before I did so. In fact, what is 1 minus 3/4? Okay. That is 1/4, right? Well, what's the same as dividing by 1/4? Multiplying by 4, right? Okay. So that way you don't have to type in a fraction, but even if you go ahead, type it in, you're still going to end up with the exact same thing. Just might make your life a little easier there. And algebra's fun, right? There you go. See, it's always fun. Right, Kiana? Absolutely. Okay. So let me go ahead and type in the original we had here. Why not? Control divide, so we had 24, parentheses, it was 1 minus. Now I am going to go ahead and do this. I'm just going to go ahead and plug in 0.75 in place of the 3/4. We want to raise that to the 12th, and then I'm going to go ahead and divide that 1 minus, and I'm just going to go ahead and plug in 0.75 as well. Okay. Did everybody agree? Okay. So what am I getting when I push enter? Okay, so 92.9591. So I'd probably say, 93 if you were to go ahead and round it. Okay. In fact, what would that be to 3 sig figures? 93.0. Okay. All right. Questions? Okay. Next up, the second term of a geometric series is -30. Oh my gosh, is it already after 2 o'clock? Man, time really does fly when you're having fun, right? It's like we just walked in here. Okay. The second term of a geometric series is -30, and the sum of the first 2 terms is -15. Find the first term and the common ratio. Because, of course, you're going to have these types of problems where it's going to have you work backwards and find all these different ones. They can't all, they're not all going to be as straightforward as just plugging into your formula. Does anybody want to come on up here and show me this one? So many hands, I can't decide. Okay. Well, what do we know so far? Okay. Okay. We know the second term is -30, right? So u sub 2 equals -30. All right. And then it says the sum of the first 2 terms is -15. So I'm not even going to need to use a summation formula that we just had to help me out here. Whatever the first term is plus the second, the sum of the first 2 terms has got to give me -15. Okay. So immediately, what is u sub 1? Yeah. Okay, so we found the first term. All right. So if the first term is 15, and the second term is a -30, well, what's the common ratio? It's got to be -2. Okay. I can just take the second and divide by the first. Okay. How are we doing? Okay. All right. Now, I believe we're to our last example. Okay, is that right? Because I think after that, yes, okay, then we have the assignment. Okay. So a company is offering a bid, hope I said that right, a job with an initial annual salary of $28,000 and a 4% raise each year after that. This 4% raise continues every year. What's the salary going to be after 5 years? Now, you got to be careful about this one. Is it a summation? Okay, so I already have one person shaking his head no. What would you guys think? Yes or no? Would I want to use one of those summation formulas we were just looking at? No, because they're not going to wait until 5 years to go ahead and give him his accumulative value, right? Okay, we just want to know how much he's going to be making at the end of 5 years. So if we go ahead and look at this from an exponential point of view, okay, the amount equals, well, what are we starting with? 28,000, that's my initial. Okay, times, John, what would my base be? Oh, not 5, that's the time.
4%.
Okay, so 4% is going to help me. Remember the base, we add or subtract that percent to what? 1. Okay, that's what's going to give me the growth or decay, because that's why one of the restrictions we have, if you're talking about exponentials, the base can't be 1, because what's 1 to any power? It's just 1, right? So that would have no change. So in this case here, John? Oh, what's that? 4 would be part of it. So remember, we want 1 plus because it's increasing, right? What's the percent we're increasing? So what's that as a decimal? 0.04. So my base would be, there you go. There we go. And then where would I put the 5? Okay. There we go. Is everybody okay with that? Okay. So let's see, 28,000. 28. I don't know why this is doing this today, but okay, 1.04 to the power of 5. So how much will he get paid after 5 years? Remember, this is not total of all those years added up. It's just this will be his salary for the 5th year. Okay. I'm getting 34,066. Is that what you guys are getting? Okay. All right. Now, is it reasonable to go ahead and put decimals on this one? Why? Yeah, because we're talking about money. There we go. So 34,066, and I'll go ahead and say 30 cents. There we go. Okay. And then calculate the amount of money he'll earn after 15 years. All I got to do is replace one thing. Okay, now we're going to replace the exponent. So 28,000.
Is it how much he makes? Or...
You know, this is another one of those problems where it's the way it's worded. Because of the type of problem, I would immediately think it's just asking about the 15th year. But I can definitely see it says will have earned after 15 years. So what do you guys think? You think that's a summation? Okay. All right. Then let's go ahead and treat it as a summation. Okay. So here's the thing. How do we know which formula to use? Would I use the first one or the second one? The second one. Okay, because our rate, okay, well, this common ratio, it's going to be multiplied by 1.4 every time. Okay. So I'm going to use this guy right here. U sub 1 times r to the n minus 1 over r minus 1. And I'm probably going to forget that by the time I get over here. Let's see. Times r sub n minus 1 over r minus 1. No, I made it. Okay. All right. So let's see. We started out with, how much was it? 28,000. Okay. Times r. What's my common ratio? 1.4 to the, oh, I was just saying if you were paying attention. 1.04, and obviously you were. To what power? 15 minus 1 over, I would just say 0.04. Is everybody okay with how I got that? Okay. In fact, it doesn't look like I'm going to have time to type it out. Does anybody have that answer for me? 560,660. Okay, that's what Spencer's telling me. Would everybody agree? That's what you got? Perfect. Okay, excellent. Okay, geometric sequences and series. How we doing? Okay. So I think what we're going to go ahead and do tomorrow, we'll come in, we'll get the quiz done first. Then I'll go ahead and pass out your homework, and I'll just give you the rest of the time to go ahead and look at it. And then we'll start the next lesson on Friday. All right. Okay. Thank you very much, folks. If you have any questions, let me know. I will see you tomorrow.